Hey everyone, and welcome. So many of us are plugging generative AI into our applications. And Kubernetes, well, it feels like the most natural place to run it all. But here's the catch. These AI workloads are a completely different beast. So let's dive into the essential cloud-native toolkit you absolutely need to get this right.
So, what is it that makes them so different? I mean, really, why can't we just run them like any other app? Well, it turns out that the apps we're used to and these new Gen AI apps, they have fundamentally different DNA. We've spent years getting Kubernetes just right for one type of workload, and now the rules of the game have totally changed. Okay, so here's the core of the challenge right here on the screen. Our standard apps, we know them. They have pretty predictable traffic patterns, and they mostly just need CPU power. But Gen I apps, they're the complete opposite. They're all about sudden, massive, unpredictable spikes in traffic, and they are incredibly hungry for those super expensive GPU resources. Getting this difference is, well, it's everything. And that tees up our first major topic. We're going to frame AI not as some impossible problem, but really as the next big, exciting challenge for Kubernetes. I mean, the platform is unbelievably powerful, but straight out of the box, it just isn't tuned for this new world of intense, spiky workloads. It needs the right set of friends to help it out. So where do we even begin? Well, you can't build on a static foundation when your workload is this dynamic. Just think about it for a second. Gen AI features get triggered by users typing in prompts or by streams of new data. It's all event-driven. That means our infrastructure has to be reactive, super scalable, and really lean if we don't want to burn a mountain of cache. And for that reactive foundation, our toolkit has two absolute superstars. First up is Knative serving. It is perfect for things like LLM APIs because, and this is the magic part, it can scale your pods all the way down to zero when nobody's using them. Think of the money that saves on idle GPUs. Then you've got KEDA, which just extends that power everywhere else. It lets you scale based on, the length of a Kafka queue or some custom Prometheus metric. Together, they create that agile, cost-effective base we're looking for. All right, with that foundation in place, now we can get into the really fun stuff, tackling the specific puzzles that come with serving large language models. This is where we get into the nitty-gritty, the day-to-day challenges of making this work in the real world. First on the list, autoscaling. Like we said, traffic to LLMs can just explode without any warning. It can go from 0 to 1,000 in a split second. Your standard off-the-shelf autoscaler, it's just not going to cut it. You need something way more sensitive, something that can be fine-tuned to the very unique signals of an AI workload. And here is the dream team for that job. For those custom event-driven metrics, like maybe counting inference tokens, KEDA is your go-to. For just raw HTTP traffic spikes, Knative has your back. Then there's the vertical pod autoscaler, or VPA, which is awesome for automatically tuning how much CPU and memory each pod asks for. And sitting on top of it all is KServe, which is built from the ground up for machine learning, so it just natively gets concepts like inference throughput. Okay, our second puzzle, Gen AI can seriously feel like a black box, right? When a model spits out a really weird answer, how do you even begin to debug that? You absolutely need rock-solid metrics, traces, and logs to get a real picture of what's going on under the hood. And to shine a light into that black box, we really rely on two key players. OpenTelemetry is becoming the standard for getting all of your signals, your logs, your metrics, your traces, into one single unified stream. It's fantastic. Then you have Prometheus, which acts as the bedrock for monitoring all that data, and crucially, alerting you the second resources are getting strained or performance starts to dip. Now for a challenge that is super interesting and pretty unique to the Gen AI world, prompt drift. Look, we all know that models can get stale over time, but it turns out the prompts we write, the very questions we ask, can also get stale. They can lead to worse and worse results as the world, changes around them. The ecosystem has come up with some amazing tools for this exact problem. For watching drift happen in real time, evidently AI is just fantastic. To track how well your prompts are actually doing over time, tools like LangFuse and Prompt Layer are basically your analytics suite for prompts. And for that critical safety layer, LLM Guard acts as a security guard, making sure your model's outputs stay safe and on topic. And the final serving puzzle is the big one. It's the one that hits the wallet. Cost. LLMs are just incredibly resource intensive. They demand huge amounts of GPU and memory. And if you don't have smart scheduling and management, you can waste an absolutely massive amount of money on hardware that's just sitting there,
not doing much. So to wrangle those costs, it's all about managing your resources like a hawk. At the node level, tools like Carpenter or the classic cluster autoscaler are perfect. They provision those expensive GPU nodes only when you actually need them. For big, complex jobs like training, a tool called Kueue acts like a bouncer at a club. It won't let a job in until there's enough space on the dance floor. And Kubeflow Pipelines helps you orchestrate all these complex ML workflows from start to finish.
All of this stuff we've talked about, it's leading to something bigger. We're moving past just serving models and into a much more mature discipline, ML DevOps, but specifically for GenAI. It's not just about the model anymore. It's about the entire lifecycle, the prompts, the routing, the evaluation, the whole shebang. A huge part of this is something people are starting to call prompt ops, and it should look really familiar. You start treating your prompts just like code. You version them in Git, you deploy your changes through a CI/CD pipeline with a tool like Argo, you monitor their performance in production using Prometheus, and finally, you use something like KServe to dynamically serve different versions to see what's actually working best.
One of the most powerful techniques in this whole new world has to be the shadow deployment. The idea is simple, but it is brilliant. You deploy your new prompt or model silently, right alongside the one in production. It gets real traffic, but its answers aren't sent back to the user. This lets you safely see exactly how it's going to behave in the wild before you actually flip the switch. It's incredible.
Now, to pull off a sophisticated move like a shadow deployment, you need a few cloud-native powerhouses all working together. You need a service mesh like Istio to be the traffic cop, handling all that complex routing. You need Knative to manage the scaling and requisitioning for the shadow service. And you need KServe to tie it all together, managing the model's lifecycle and making the whole process feel seamless.
The final piece of this ML DevOps puzzle is automating your testing to make sure your quality stays high over time. This is where continuous evaluation pipelines come in. Kubeflow Pipelines, again, is a key player here for orchestrating these workflows. And tools like MLflow or weights and biases are just crucial for logging every single prompt and model change, giving you a perfect, auditable history of everything you've ever tried. So as we start to wrap up here, it's pretty clear that running AI on Kubernetes isn't just about installing some new tools. It really demands a fundamental shift in how we think about the very building blocks of our software. There's a quote that just says it all, really. Prompts aren't just strings, they're assets. This is the new mindset. They have to be versioned, deployed, and monitored with the exact same rigor we apply to any other piece of production code. And evaluations? They're not just some script you run once. They are automated, continuous pipelines that are always running. And that brings us to the final thought. The cloud-native ecosystem gives us this incredible foundation. All the tools we've talked about, they're here. So the real question to leave you with is this. Are you leaning into that ecosystem? Is your AI workflow actually evolving to keep up with your infrastructure? Thanks for watching.